Hello, this is a lesson on mean, and you'll get to see a little bit about frequency tables and stem and leaf plots. So let's just jump right in. The mean is a measure of central tendency. So when you're doing basic statistics and it's asking for the mean, you're trying to get a picture of where the center of your data is. So mean, median, and mode are all your measures of central tendency. And today we're looking at mean. You might recognize mean as the word average. It's a little thick. So if you're finding your average for a grade, you're getting an overall picture of what your performance was in the class. So if you have a B in the class, then that means that you probably had some grades above a B and below a B and maybe equal to a B, and it centers on B. Or maybe you had all Bs. So it just gives a nice picture of where your data is. So here's some other examples of where you might see the word average or mean. On average, what would you guess the number of hours of sleep you or your classmates get a night? And on average, what would you guess the average distance you and your classmates are from your hometown? So average can really be anything numerical which is quantitative. So the word quantitative is like quantity, and that's numbers. So anything that can be measured in numbers, you can find the mean of. And it's really pretty simple. Mean is obtained by adding all your data items and then dividing by the total number of items in the set. So the formula for mean looks like this crazy symbolism like this, and what it means is the wording above it. So this crazy symbol right here means the sum of. And then this x sub I means all the x's in the set. So x sub 1, x sub 2, x sub 3, x sub 4, and so on. So if there's 10 items in the set, then it would go up to 10. Your I would go up to 10. And then it has this, divided by n, where n is the number of items in your set. So this means what it says above. Add all items, divide by the number of items or elements, would probably be a better word, but it's okay. And the symbol for mean, which you'll see in textbooks, the symbol for mean is X bar, and that's how you say it. X bar. This symbol is a shortcut for the word mean. And so you'll see in textbooks this formula, X bar equals the sum of all the x's divided by the number of elements in the set. So when you see this crazy symbolism, that's just mathematical notation for the mean. Mathematics kind of has its own language with its own symbols, and so it's kind of like you're learning a second language when you learn math. Let's just look at a couple examples here. I don't have a whole bunch of examples because it's really pretty straightforward. The reason why I've added in the frequency table and the stem and leaf plot down here is because mean is pretty simple, and I wanted to add in some elements that maybe you haven't seen before or might confuse you in homework or tests or something. So this is a frequency table, and it lists the data items in order and states how often each item occurs. Okay, so it's not to be confused with a data item, all right? So let's look at this table, and part of statistics is learning how to read a table and read it effectively. This says scores, which are our x's. So 60 is a score. 70 is a score, and so on. And then the bottom row says frequency, F. Frequency, if you think about the word frequency, what does that mean? How often it occurs. So 60 occurs 3 times. 70 occurs 4 times. 80 occurs, and so on, okay? So frequency is saying, for example, this is scores on a test, so 3 students made a 60. 4 students made a 70, and so on. So it's just kind of a way of condensing a large table where all these scores are written out the long way. You can organize it in this table called a frequency table that makes it a little bit easier to read. Fill this in. 60 occurs 3 times, 70 occurs 4 times, etc. So if we were to find the mean score, the center, like on average what this class scored, or maybe it's one student and those were his or her scores, doesn't matter. There's 2 ways you can do this. I'm going to show you the way that if this were listed out the long way, what it would look like, okay? So the mean is, it says that 60 occurs 3 times. It says 70 occurs 4 times. It's a lot of 70s. And then 80, 2, 3, 4. I'm going to run out of room. Maybe not. Oh, only 190. And then we divide by how many items there are. If I were to say, oh, there's only 1, 2, 3, 4 items. Is that correct? No. I will tell you, no, it is not correct. There's not 4 items. Look at your list here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items. Where could we get that number from the table? Let's look at this bottom row right here. Isn't this so neat? 3 plus 4 is 7, plus 4 is 11, plus 1 is 12. So that's where this 12 is coming from, that frequency. That's the number of items in or elements in this set. So we're dividing by 12. I want you to be really careful here. If you're using a calculator to find the mean, I would either recommend doing 2 separate steps. So you add the items, get your sum, and then divide by 12 to get your mean. Or if you want to do 1 step, make sure that you put your numerator in parentheses, because you need to tell the calculator, I want to add all of these numbers and then divide by 12. And it does matter. If you have a newer calculator where there's a fraction button or it has a template like a little box and a bar and a little box, then you don't have to worry about parentheses. But in some of the older calculators, you do have to worry about it, because if you don't type it in correctly, then you will get the wrong answer, and it is not the calculator's fault. It's your fault. Sorry. User error. The other way to write this, which I prefer, and it makes a lot more sense, and it takes a lot less time and a lot less space, so it's wonderful, is we can use the frequency table to our advantage. We can say 60 occurs 3 times. 70 occurs 4 times. 80 occurs 4 times. 90 occurs once. And then we're still dividing by 12. There's still 12. And like I said earlier, you can do it in 2 steps where you do the numerator first, divide by 12, or if you're typing it in a calculator, make sure you're doing parentheses around the whole numerator and then telling the calculator, I want to take all of this and divide by 12. So if we do that, see if I can find my calculator app. This is a free app. We can do, I'm going to do parentheses, 60 times 3, close it. Oh, sorry, don't close it. I was thinking wrong. Plus 70 times 4, plus 80 times 4, plus 90. Now close it. Okay, your calculator will know PEMDAS, so order of operations. So your calculator will know that it needs to multiply those pieces first and then it will add. So I don't need all these extra parentheses in there. I just need the parentheses around the whole numerator. And then I'm dividing by 12. And we get 72.5. So on average, this either student or class had a passing score. That's the mean, that's the center. So if we were to look at like a dot plot or something and all the dots were gathered, they would all center around about 73. Okay, this is a stem and leaf plot or table, either one, where the stem represents the first number and the leaf represents the last number. Now these are 2-digit numbers. If it's a 3-digit number, then the stem would represent the 2 first numbers and the leaf represents the last number. So basically what I'm saying is the leaf always represents the last number. So this is, if we were to write these numbers out, 21, 24, and 25. This is 30, 31, 31, 33. And this is 42, 45. So the stem and leaf is just a way of breaking up your data. It kind of shows you the shape of the data. If you tilt your head, you can kind of see the curve of it. So you can really kind of see like, okay, most of these are in the 30s. Very few were in the 40s. Now, if you had more data, this would make a lot more sense and you would get a better picture of it. More data is always a good idea as long as it's unbiased data. But for the sake of this lesson, the small set is fine because it's easier to compute the mean. All right, so when we're finding the mean, we use our stem and leaf to have our numbers here. And then we just calculate the mean. So we add up all of our numbers. I might run out of room because I started a little big. Let's see. Nope, I'm going to be okay. You never want to worry about taking up too much space in math. You want to try to stay as organized as possible, and that takes space. So we're kind of paper wasters. I actually don't use paper. I'm using an iPad, so I'm not wasting paper. I can use as much as I want. So that's an advantage to using, going paperless, is you don't have to waste paper. You can use as much space as you want, but it's very important. It might seem wasteful, even if you're on paper. If it might seem wasteful, but you gotta be organized in math. You gotta. Okay, and then we're gonna count the number of items. Sorry, side rant. 3, 6, 7, 8, 9, 10, 11 items. And then I just type it in the calculator. Or you can add it by hand if you want to, which is fine. Let's see. I need to be able to see the numbers, so I'm going to grab this calculator. You really don't need a fancy calculator for this. Fancy calculators are nice for statistics because they can do a lot of the harder computations super quick. So I could type this in a table, figure out the mean very easily, but I am going to do it by hand for the sake of this lesson because I'm teaching mean, so I want to show you how to do that. So I'm just going to make sure the biggest mistakes happen in when you type in the wrong numbers or you forget your parentheses. So you need to make sure that you're typing in the correct numbers. So I have my home screen here, and I'm going to type in, I do have a fraction button, so hopefully you can see it. It looks like this, has that box divided by a box. So I don't have to worry about parentheses in this case. I can just type in the numbers. 21 plus 24 plus 25 plus 30 plus 31 plus 31 plus 33 plus 42 plus 45. At this point, you might think, I'm a great typer. I'm just going to keep on going. I'm good. You need to check and make sure that you typed in those numbers correctly. So go back, check and make sure. There should be 11 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I do something wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted wrong the first time. See? Accidents happen. That is a 9, not an 11. 3, 4, 5, 6, 7, 8, 9. So I'm really glad that I went and double checked that. I am an expert. I'm a mathematician. You would think that I don't make those mistakes, but everybody makes mistakes, and so that's why you have to go back and check it. So there are 9 items. Now I know that. Now I'm going to check and make sure that I typed in the right items. 21, 24, 25, 30, 2 31s, 33, 42, 45. My numerator is correct. And then 9 goes in the bottom. So I'm going to hit enter. My calculator returns a fraction as the answer. That's okay, but I really want a decimal in this case. So I'm going to do Control Enter to get a decimal. Depending on your calculator, it might be different. Some of the scientific calculators that are not graphing have a button with an S, 2 arrows, and a D. That is your button that converts from fraction to decimal. So if you're working with a different calculator, you might locate that button, and that's your guy. So our average, this is a rounded number, so I'm going to put about 31.3. And that's all. You're done. That's mean. I hope you enjoyed the lesson. If you have any questions, please let me know. You can email me or you can comment below, and I would be more than happy to help you. I hope you enjoyed it. Bye-bye.